Hey, welcome to another how-to series. In this session, I want to show you how to configure our universal monitoring agent with Prometheus. Okay, in the past, we have shown you how to deploy UMA, Universal Monitor Agent, or UMA for short. We actually have a video in YouTube. If you go to YouTube and you do a UMA deployed search, you'll be able to get this how to deploy Universal Monitoring Agent. So go ahead and follow that if you want to follow instructions how to deploy it. Today I just want to show you prior to deploying it, how do you configure it to report Prometheus metrics. All right, so to that end, we have our environment set up. I have our sample application demo app, Ticket Exchange, as you've probably seen in the past. It has been deployed it's deployed in Kubernetes and it's functional. It's up and running. So now what I want to do, I want to show you guys that I have Prometheus deployed on my Kubernetes. So first of all, let me go to my console, do a kubectl, get nodes, and show you the three nodes that are part of my Kubernetes cluster. And I'll also do a kubectl get pods. And Ticket Exchange is deployed in the namespace called Ticket Exchange. So if I get pods for that Ticket Exchange namespace, I see my three pods, right? My web services, authentication service, my web portal, and my database, my SQL database. All right, so let me show you. So I have Prometheus deployed. Here's the Prometheus URL going in on that Kubernetes cluster. So let me show you, for instance, nodes. If I do node info execute, you can see that the three node info in my Kubernetes are the 34, 36, and 35. It's the same nodes. And if I were to do, let's say, pods, status ready, well, if I'll execute this, I get the status of all the pods. I'm going to narrow this down to Ticket Exchange. And as we did before, get pods in Ticket Exchange. There's three pods in there. So let me go in here and execute. All right, so these are the three pods, right? The database, the web portal, and the web services, right? Okay, so let me show you now how to configure. Now that we know that we have Prometheus deployed on our Kubernetes environment, as well as Ticket Exchange running in Kubernetes, let's go ahead and configure our UMA so that it so that it can scrape data metrics from Prometheus. So this is a default YAML, UMA YAML. Again, we're showing you guys how to configure the URL and credentials in order to connect to the right SaaS environment. All I'm going to do in this session is show you just the two parameters, attributes that I need to modify in order for UMA to actually scrape and report Prometheus data. So it's asking me for two things. It's asking me for the cluster name, and it's asking me for the Prometheus server URL, right? It needs a server URL so it can connect and get data from there, right? Scrape data metrics from Prometheus. So the cluster name, it's whatever. It's just a label. I have my Kubernetes deployed in our Broadcom private cloud. So I'll call this private cloud Kubernetes 8 cluster. All right, so that's the name that I'll give to my to the reported Kubernetes cluster by UMA. And now the URL, I can get it from here. Prometheus. In my case, let me copy this. Has been deployed. I have deployed my Prometheus server as with a service node port. And this is the node port that I got. Now, of course, if you have deployed it, if you have put some sort of authentication or a token on your Prometheus, then you can pass that along. You can put your username, password, or the token itself for us to communicate, giving UMA permission uh, to connect and scrape metrics. All right, let's save this. So I'm going to go ahead and save this, and I'm just going to deploy it. That's all it is to it. All right, so let me go in here and then do kubectl, create -f, and here's the YAML that I just configured. So just going to deploy it and just deploy it, right? So if I take a look at my pod, kubectl get pod, and the name of the namespace where we're deploying this UMA is called CA APM, and I can see that methods pods are running. So now this is my APM SAS. I'm going to go ahead and use SAS in order to demonstrate this. So if I log into my APM console, and if I go to my metric view, I see that there's nothing currently being reported. So it's just a matter of seconds for my UMA agents to start reporting. So I'll go ahead and refresh it, and there we go. And we're starting to get metrics, right? The agents are reporting. I can see these are my working node metrics. Again, we went over this on the previous video. What I really want to concentrate is on this cluster, okay, that I just configured. So if I open that up, I see that I have two agents reporting into here. One is called cluster deployment, and the other one is called cluster performance. So basically, one is just providing information about the deployment that I have out there. So for instance, and again, I'm not sure if all the metrics are currently reporting. I'll open this up. No, not yet. So they'll come in a few seconds. Let me see the performance agent. If I open up the performance, yep, performance is reporting right now. So I'm seeing some of the cluster performance as well as some of the namespace, right? If I open up namespace, there is our ticket exchange. If I open that up, I see performance on the namespace themselves, right? All namespaces have sort of the same information, right? How much CPU, memory, and so on and so forth disk is being consumed at the space level, as well as, right, the pod level. So if I open up here my various pods and ticket exchange, I can see, for instance, on my SQL, the various performance metrics, as well as I can drill even farther down, right, to the container. In my case, I have a one-to-one, but you can have many images, containers running on a pod, and I can get the breakdown of the various containers images within the pod. Could be very useful if I'm trying to troubleshoot one image from the other. Okay, this is good. Now, the other thing, obviously, and again, you learned that from their previous video on UMA. UMA also discovers and can auto-instrument applications. In this case, you can see that if I close this, my web portal application is also being reported now by UMA, right? As well as my authentication service. It's great, right? So UMA has actually, I just deployed UMA, and it's out of the box, it's able to starting to report some of the Prometheus metrics after I configure it and letting it know what the Prometheus URL is along with the port, and of course, just as before, it's monitoring my my application. So now, well, let's concentrate on the Prometheus metrics, right? So I just showed you a few of them. It's excellent. Let's go back into them. Let's take a look at deployment, for instance. Maybe the metrics are back already. Yeah, they're reporting. If I open up my namespace, again, I'll pick any namespace. We're familiar with Ticket Exchange. Let's pick Ticket Exchange. And it's just going to show me the number of pods, right, that are in that namespace, the number of deployments, within, the various deployments that I have, and within each deployment, the number of replicas and deployment health and so on and so forth. Uh, Again, very useful information, but really a little bit hard if just going to monitor or um, troubleshoot, just understand the performance just by looking at the metrics, right? Hopping from one metric to the other, it's not the best way. What we want to do is we want to leverage dashboards so that it can show us at a glance, right, the performance of our entire environment. So to that end, so let me go ahead and show you our dashboards. So we're going to jump into our dashboards console. I have Prometheus, so we have Prometheus dashboards. I have a Kubernetes dashboard. Let's start with this one. So if I go into my Kubernetes cluster dashboard, I can see I have a Kubernetes cluster overview. What this is showing me now is the same metrics that I showed you earlier, right, from the cluster performance, but obviously, it has aggregated, or it has taken all those data and shown me in a single pane of glass, right? So that at a glance, I can see the name of the cluster that I'm monitoring, the total number of nodes that compose that particular Kubernetes cluster, the total number of pods that are actually running on my cluster, right? As well as one other thing that we're reporting, the status of the API server, right? This is critical. As you guys know, uh, the only way for me to communicate, the way I communicate with my Kubernetes, which is through my master, is by talking to the API server. So if the API server is down, then I have no way to communicate, right, with my Kubernetes environment. The other thing that this is showing me, and that I get information from within this dashboard is the total number of CPU cores available for my cluster. This could be very important, right? The total number of the memory capacity that has also been allocated for this cluster to use, storage capacity, as well as the network. Uh, I can see, for instance, that about 19% of my CPU is currently consumed within my cluster. 37% of the memory allocated to my Kubernetes cluster is being actually used up, uh, as well as some network utilization and so on and so forth. All right, this is good at the cluster level. Now I can do better. I can, I was looking at this information from a cluster perspective. Now I can take a look at them from a working node perspective, right? So for instance, in here I have total number of working nodes is 3. So I have a drilled in link that I can click on. And this is going to take me to another dashboard that's actually going to show me the detail of a particular node, right? So let's change node. So I'm looking at 34 right now. Let's pick, for instance, 35. If I change the node, my dashboard updates, and it shows me the internal IP for that particular node. It's showing me that this node is ready to accept pods. That means it's in ready mode. Showing me the capacity uh, of the number of pods this particular node has been configured with, as well as the CPU, number of CPU, number of cores, and CPU cores in this node, utilization, memory, disk, as well as network. Okay. One interesting thing that I want to bring your attention to is this memory pressure, disk pressure, as well as network unavailable. Okay. What these are Kubernetes terms that actually Kubernetes tracks in order to understand if this particular node is ready to or able to take on a new load, able to deploy new pods, right? So, for instance, we have a linked in here that will actually take me to the definition of these, right? So, for instance, I can see what memory pressure uh, is true. Memory pressure is true if the pressure, if the node is has the node in the memory is low. right? Otherwise, it's false. And so what happens with this, as you guys may know, whether it be, these are labels, right, that a node gets when the node runs low on, on disk, on memory, or the network's unavailable, whatever it may be. Once these nodes get labeled with this particular uh, condition, then the Kubernetes scheduler will actually skip this, won't use this node in order to create and deploy new pods in that node. And so this is something obviously that you want to keep a very close eye on, because obviously if these guys are, memory pressure is true, then we know, right, that Kubernetes won't be deploying any new pods in this working node. Okay, so this is an alarm. So for instance, if the memory pressure were to go to true, this will turn red and it will show memory pressure equals to true. All right. So the other thing that I want to show you in here is the total number of pods. Okay. So now I may want to go ahead and take a look in more details at the various pods that are actually deployed. And so for that, I'll go ahead and drill in my pods detail dashboard. And in here, I can see that the first half of the dashboard, it's got information, per namespace. So that is giving me information at the namespace level. It's telling me, in this case, we have selected Ticket Exchange. It's telling me the number of deployments, pods, and services that I have, that are actually running or deployed in this particular namespace. It's telling me the CPU consumed in this namespace, as well as memory, network, and so on and so forth. Of course, I could change this. I could go ahead and let's take a look at APM, for instance, namespace. This is the namespace where actually UMA and all its pods gets deployed. So let's take a look at the performance of that namespace. So if I select that, I see there are 3 deployments are composed of 6 pods. I can see that CPU being consumed by these pods, as well as memory. Now, the second half of this dashboard, it just shows me, it goes into details of all the pods and containers being deployed on my cluster. So for instance, this is the CPU utilization by all the containers deployed on my cluster, right? I can easily, I have the max, the average, and the current value, right? The last reported value. I can sort by them if I want, or I can actually, search. Maybe I'm looking for Ticket Exchange, and I can see the Ticket Exchange containers, and I can look at the CPU consumption of them. Same applies. This is for the network utilization of all the various pods. Uh, I also have, the memory for the various pods, the memory usage, the read and write of each container. Okay, that might be something that I may want to track, and so on and so forth. So you see, UMA is able to report this, but very nicely capture this information, right? All these metrics, turn them into information by displaying them in a very concise dashboard that, shows me at a glance the performance of my cluster, the performance of each individual working node, or the performance of my pods and container, right? This is good, but of course, we also mentioned that we UMA also monitors the application itself, and this is the value added that UMA brings in, right? In addition to reporting Prometheus metrics, we also go into the app, as you guys know, instrument the app and report those metrics. So again, if we take a look at those dashboards, my Ticket Exchange folder, I'll go ahead and select the Ticket Exchange application. So now, now I'm seeing metrics for my specific application. I can see, for instance, the business overview. It should show me at a glance the number of searches, number of new orders, number of logins, number of items added to my cart. That might be critical for me. as well as my end user experience, right? This is the performance, this is the response time from an end user perspective. This is what, performance coming from the browser itself. This is what the response time that my end user is experiencing. As well as my application health, I can see that I have some actually errors. Uh, so far I have reported 166 transactions, and 10 of them have errors. There's no stalled transactions, and there's not any backend error right now. Okay, so this is something that I could go ahead and investigate further. And lastly, the resources consumed by my application, the CPU, the heap, and the thread pool. I can see that the CPU is low, the heap is 63%, and the thread pool is just 1%, right? So I can go ahead and, again, drill farther down into heap to understand what's going on. So I'll go ahead and select. Okay, so now I'm looking at my GC heap detail dashboard. I can see now at a glance the memory pool, right? What's my uh, all generation space configure, as well as my eating space. I can see the number of the growth rate, how many objects are actually being, created and garbage collected, as well as the performance of my garbage collection. Right, as you guys know, every time garbage collection kicks in, my application pauses. So it's something, critical that I want to track, right? Because if my garbage collection takes seconds, that means those are seconds that my application is not running, right? It's in post mode. All right, so I think this is all I wanted to show you guys. Let's go back into, take a look at the Kubernetes. Okay, so the purpose of this was to show you guys how easily it is to configure UMA to actually scrape and report Prometheus metrics into APM, and also how we can leverage our DX dashboards in order to convey information better for you guys, right? Something that makes sense just by looking at a single dashboard. All right, I hope this was helpful. As always, let me know if you have any questions on this. Thank you.